In this lesson, we're going to examine some other relationships that can exist because of scatter plots. In particular, we're going to look at ones that create linear relationships, generally lines, and ones that are nonlinear, basically curves. We're going to start by looking at some examples. Here we got Jordan and Corey working on a science fair project. They're investigating whether a dog's mass is related to its height. Here's some of the data they've collected. So, what are we starting with? Graph the data, draw a line best fit. So this time they haven't given us any information about our scales or even our variables, but we always know the bottom one comes first, so our height should go across the bottom. And up the side is going to be our mass. Here we got to pick a scale. So let's take a look at our numbers. The big number looks like 69. The smallest one's 27. So if I'm going across the bottom, and we always start at 0, it kind of makes sense to go by something that's going to get me to around 70. So let's give this a try. How about 10, 20, 30, 40, 50, 60, and 70? That way, each one of these dashes in between is worth 2, right? 2, 4, 6, 8, 10. Kind of handy. Oop. Okay, how about up the side? I go from 5 to 35. So I don't have to pick the same scale. Maybe I can try 5s. So 5, 10, 15, 20, 25, 30, and 35. As long as my data fits, my scale is my choice. But I gotta pick some sort of pattern. It's still about patterning. Okay, let's plot the data. 69, 35. I'm gonna erase some of these by accident here. 60 and 70. 69 and 35 is about right, I'd say right there. 59 and 32, that's going to be about there. 54 and 23, 23 right there. It's a nice one. 46 and 17, 46, 17, about there. Oh, that's over to the left. So 44, right? 46 and 17 should be there. 38 and 14 should be there. 31 and 6, go there. 28 and 8, 28 and 8, and 27 and 5. 27 and 5. Okay, there's my dots. They're following a pattern. My line of best fit, I were to take my ruler and draw it something like that. Maybe it's a little bit higher, right about there, I'd say. So I end up with 3 dots below. I've got 4 dots below, 4 dots above, but they're not very far from my line. Okay, there's my scatter plot. Let's describe some relationships. Well, it seems as height increases, so as I go towards the right, the graph goes higher. The mass also increases. How would we describe that correlation? Well, that would be our positive correlation, right? This is our trend. Okay, estimate the height of a dog with a mass of 16 kilograms. 16 kilograms. Well, that's over here, 16. So if I follow along my graph and then I go down, I can estimate it to be approximately, I'm going to say about 43 kilograms. Oh, sorry, 43 is height, centimeters. Okay, if it's 50 centimeters, I can do the opposite. Here's 50. I'm going to follow up. I'm going to go across. Say it's about 21 kilograms. A dog with a height of 30 centimeters has a mass of 15 kilograms. 30 centimeters, 15 kilograms. 30 and 15. That's right about there. Ooh, that's weird. Does this dog follow the trend? Well, let's take a look at our line best fit compared to that dot. Doesn't that dot seem like a long ways from the line best fit? I would say no. This dog doesn't follow the trend. In fact, if I were comparing him to normal, he's supposed to be down around here, right? He seems much heavier. He's almost 12 kilograms heavier than he should be. It is much. This is kind of the stuff we were doing yesterday, right? But we're using our line best fit a little bit more and describing what's going on here. Okay, would you agree this is linear? It basically follows a straight line. Not perfect, but pretty much up and to the right, the blue one. Well, not every graph does that. If you make a graph that doesn't really make a straight line, it kind of curves. Well, we call those things nonlinear relations. If you have a nonlinear relation, you can't make a line best fit because it's not a line. So instead, we're going to draw ourselves a curve of best fit. Let's take a look at one. A ball is thrown into the air and its height is measured at regular intervals as shown in this table. Let's graph our data. So as usual, our graph here, the bottom will be the first thing. In this case, it was time. Got to pick a scale. And the up and down part was the second one, which is our height. So my time is going up to 3.5 seconds by 0.5s. If I start at 0, 1, 2, 3, 4, that would make these a 3.5, right? 2.5, 1.5, and 0.5. It's kind of nice. My maximum height I get to, it looks like 20 is the biggest number, and well, I got to start at 0, so I can go by, what do we want to go by here? Let's call these 5s, 10s, 15, 20, 25. That should fit pretty nicely. Let's plot our data. What do we got first? 0.5 and 9. 0.5 and 9, I can graph that one perfectly. Okay, 1 and 15, 1 and 15. 1.5 and 19. 2 and 20. 2.5 and 19. 3 and 16. And the last one, 3.5 and 10. Okay, here's my graph. Which seems more appropriate, a line or a curve of best fit? Well, looking at the data and even thinking about the idea of throwing a ball in the air, it seems to me it would make much more sense for it to be a curve of best fit. Don't you think? Now my curve kind of missed some of those dots. I should probably fix them a little bit. Curves are more likely to hit the dots. Not all of them, but should be pretty close to most of them. If you think about the ball, isn't that not the shape of the ball being thrown in the air too? Okay, estimate the height of the ball after 3.25 seconds. Well, that's halfway between 3 and 3.5. It's like 3.25. So I go up, I go across. I would say the height would be about 13 meters. When do you think the ball is going to hit the ground? Well, look at my curve of best fit. This is where it started. That means where it ends would be way over here at about 4 seconds. So I can still make predictions from a curve. Just think about it being a curve. And one more for you guys. The Canadian Recording Industry Association keeps track of sales of recorded music in Canada. Data for 1996 to 2003 are shown from the graph. About how much did Canadians spend on recorded music in 1998? So here's 98. If I go up and I go across, what is that? Well, this is 1200, so that's 1300. That's 1500. Somewhere in between 1400 and 1500. Ooh, that's sales in millions. I would say 14, let's call it 25 million sales in 98. Or if you want to, that's 1,425,000. Right? That's a lot of sales. Okay, how about 2003? 2003. Oh, where is 2003 on here? I gotta figure this out. 2003. Well, this is 2001. It's every 2 blocks. 2003's got to be about there. That dot. About I don't know, 950 maybe, if this is 900? I'd say about 950. 950, again, it's in millions. Sales in '03. Okay, predict how much Canadians spent on recorded music in 2004. What assumptions are you making? Well, if we were looking at a graph and think about this being a curve of best fit, because it definitely looks curved. The graph goes up and then down. But what's happening as it go down over here? Is it continuing to go down a long ways? Like should 2004 be below 900? I don't think so. I think it's still going to be in the 900 something, but maybe it's 915 million. So it's dropping off. But it seems to me at the end of this curve is almost leveling out, right? It's creating a flat spot almost, like that. It's not very steep anymore. What assumptions am I making? I'm assuming that the trend continues. Okay? It's assuming the graph is going to keep doing what it's doing. If all of a sudden something happened and people weren't selling records anymore, well, then it would drop way off. Or, I don't know, the internet crashed and you couldn't download things digitally, well, then maybe go way back up again. People have to buy stuff. We're assuming things have to continue. Okay, describe any trends you see. I kind of see two trends in this one. I see a trend up until 1998, and then I see a trend after 1998. Okay. Up until 1998, sales are increasing. After 1998, sales are decreasing. Okay. Whenever I describe a curve, I actually have to talk about both parts of the curve. Because curves go up and they go back down. Now, if you look back to the last question with the ball, the height of the ball was increasing for over the first 2 seconds. And then after the 2 seconds, the ball was decreasing, right? That's where we got to the highest point there. Whenever I describe a curve, I've got to describe it in two ways. The first half and the second half. Just like we did this one here. Okay, that's scatter plots. We're basically all done scatter plots. All we can do with them is draw them, talk about the trends and the patterns on them, use them to make predictions. And give this sheet a try. If you're stuck, come see me.